Hello everyone, welcome to our MathShed webinar. We'll just wait for everybody to join us and then we'll start. Sorry, we're just a couple of minutes late. So today's MathShed webinar is hosted by Alex and myself, Karis, and it's on what are conceptual and procedural variation in mathematics. And we'll be going through our MathShed resources with you today and how we use these within our lessons in MathShed. So I'll pass over to Alex now. If you've got any questions at all as we go through, if you put those in the Q&A or the chat box at the bottom, and as Alex is speaking, I'll do my best to answer any questions that we get.
Yeah, thanks for that. Okay, thanks very much, Karis. Welcome everybody that's decided to spend this sunny afternoon with us. Okay, so what are conceptual and procedural variation, and why do they matter, I suppose, as well? So to start off with, it's important to distinguish between variation and variety. So variety is just having like a random mix of questions, like pick a mix. So there isn't really any rhyme or reason to it. There's just like lots of different questions. And so there's variety, but that isn't necessarily the same as variation. So you can have any worksheet you can download from anywhere or textbook, and you'll have variety of questions, but you won't necessarily have variation. So variation, and the difference between variation and variety, is that with variation you choose very carefully what it is that is varied between each question, and also often the sequence of questions, such that it means that there's a careful choice of what the variation is drawing attention to. So if you're changing one thing every time, you could be doing that for children to highlight or expose a difference that you're looking for in that variation, which is different to variety, where things are random and there's no purpose to it. Okay, so what are conceptual and procedural variation? There's two forms of variation. So conceptual variation provides pupils with different perspectives and experiences of mathematical concepts. A particular way you can foster conceptual variation in a class is using different mathematical equipment, so different concrete resources. That's a simple way to foster conceptual variation in your classroom. Similarly, you could do that with pictorial representations. So you could use part whole models as well as bar models, or different kinds of bar models and different kinds of part whole models, or part whole models, or what have you. And that's a way to build in conceptual variation from the start. Now, procedural variation is perhaps the area of variation that gets more of a write-up, more consideration. You can find, I think you can find a lot more academic writing on procedural variation than conceptual variation. And the difference there is that procedural variation allows children intelligent practice. So rather than just like kind of rote learning or drilling, there's a purpose and a thought process behind that, which we're going to look at. The way that practice is intelligent is because it focuses on relationships, so not just a procedure. So if you had a series of number bond type questions, it wouldn't just be a random assortment of number bond questions. They would be sequenced in a way to highlight each of the bonds, let's say, and for children to discuss, okay, question A was 8 plus 2 equals blank, but then question 2 was 10 equals 2 plus blank. And again, they're using the same number bonds, but in different ways. And you could discuss with them, okay, what's the same about these two numbered sentences? What's different? So on and so forth. So that's a way that you use procedural variation to sequence questions with minimal differences for children to extract similarities and differences from that and be able to discuss it, which therefore allows them to make connections between problems. But maybe we'll look at that a little bit more in depth later on. Okay, so variation is something that is very, very heavily promoted by the NCETM in England and further afield in the UK. So here they state these kind of 4 aims of variation in teaching. So I'll just state them. The central idea of teaching with variation is to highlight the essential features of concept or idea through varying the non-essential features. This is something I'm going to refer back to later on in this webinar. This idea of essential and non-essential features, I like to think about it in terms of when you're doing a science experiment with your class, you'll have dependent and independent variables. So things that stay the same and that one thing that changes. And I think it's a good structure to think about how you would organize procedural variation if you were to write a question set for yourself for your pupils. Here, as we've seen already, variation is not the same as variety. So you need to make sure that careful attention is paid to what aspects are being varied and what is not being varied and for what purpose. So it is really thinking, okay, what questions am I going to ask? What order am I going to ask them in and why? And what am I looking for the kids to extract from that? So when giving examples of a mathematical concept, it is useful to add variation to emphasize what it is. So both standard and non-standard examples, which we're going to look at later, and also what it is not. So it's a bit like teaching kids words, like doing vocabulary work and having them think about synonyms and antonyms as well to really embed that understanding of that concept or term. When constructing a set of activities or questions, it is important to consider what connects the examples, what mathematical structures are being highlighted. So again, as with the number bond example, you could have number bonds to 10 at random, or you could carefully sequence questions such that children are going through particular bonds, the 2s and the 8s to 10, the 3 and the 7, 4 and 6, and so on and so forth. And you could order it in some way that it goes up and down, like you have 1 and 9, and then 2 and 8, and so on and so forth. Yeah, we'll look at that in more depth in a moment. So students are encouraged to avoid mechanical practice. So that's like that kind of drilling rote practice, and instead to practice the thinking process. So thinking about what they're thinking about. So that sort of metacognition type of stuff. And that is where this idea of intelligent practice comes in. So here we've got these wonderful examples from the Enigma Maths Hub in Cambridge that show us, why these standard and non-standard examples that are part of variation theory are so important. And these are examples from Joe Bowler's mathematical mindset book. So children, because so often kind of traditional worksheets and resources focus on standard examples, it means that when you then show children non-standard examples, they falter. So unless you build variation into your practice in general, and it's just a mainstay aspect of your classroom practice, children will be sidelined by questions like this. So this irregular shape on the left-hand side is a hexagon, but children were unable to say that because in all of the textbooks and worksheets that they'd been shown up to that point, they'd only ever seen this relatively regular hexagon represented. Similarly, here, children were asked about parallel lines. And because all of the examples that they'd been shown and used to be taught parallel lines were all pairs of parallel lines, because there were then 3 parallel lines, children had been completely thrown by this. So again, it shows that using regular and irregular and non-standard examples, it's really key to have children have a very deep conceptualization of what they're learning in mathematics. Again, here, children were unable to identify right angles and parallel lines because, and even triangles and squares, because they were used to seeing them in one set format. So on the right hand side, you have the pair of parallel lines. One line is shorter than the other. They're still parallel. The square is not at a sort of horizontal, flat presentation. It's shown on a sort of diagonal, askew sort of angle. So children were thrown off by that. Same with the right angle triangle and the right angle by itself. Really, we should be showing children all of these and allowing them to see, okay, squares don't need to be along a horizontal line aspect for them to be a square. The same with right angled triangles, and the same with right angles. That it needs to again be part of our classroom practice that we're showing children these shapes at different perspectives and angles, such that children can identify them. 2, children should be able to go, right, well, that's not just a square and a triangle. You've asked me about right angles, and I know that there are right angles in those shapes as well. So it's all about that variety, that variation, not variety, variation that you build in to allow children to be able to identify key concepts and features of mathematics in multiple settings and scenarios, even those that are less familiar to them. So it's not just in shape that this is important. So traditionally, we might expect to see a number bonds questions kind of randomly assorted as on the left-hand side. However, there's value in doing it as on the right-hand side. And even as I referred to earlier, you might want to alternate it more such that we aren't just looking for 10 every time. We are looking, so you'd have blank equals 7 add 3, but then you'd have 10 equals 3 add blank, for example, so that there's some variety there and variation there rather as well. But the key point here is that a lot of times children are thrown by questions like those at the top and bottom of the list on the right hand side, because the sum is being sought for on the left hand side of the equal sign rather than the right hand side. So there are times when children who have had a diet of standard formatted number sentences then get shown a number sentence where the result is on the left hand side rather than the right hand side, and that in itself can throw them. So it's really important that even from the earliest stages of teaching children abstract number, that we expose them to the fact that the equals symbol is a signifier for equivalence, and that the number sentence can go on either side and the result can go on either side of the equal symbol. That's just one small tweak, if you're not doing this already, to just start having more variation in the work that you're presenting your pupils immediately. Now, for conceptual variation specifically, a key example that people use, it's in some papers that people have written about conceptual variation and how it's used in East Asian schools, is talking about elephants and rhinoceroses. So this highlights the importance of examples, standard examples, non-standard examples, and non-examples. So here we have what we considered to be a standard example of an elephant on the top left-hand side here, where it has tusks. Then we've got a non-standard example where the elephant doesn't have tusks. But because we know what an elephant is, we can go, okay, that is an elephant. It just doesn't have tusks. That tusks isn't necessarily an essential feature of being an elephant. Then we've got an illustration of an elephant as well, to show that there are real elephants, as in the photographs, but then there are also, cartoon elephants, representations, pictorial representations of elephants, and they're all the same. Now, because we have a conceptualization of what an elephant is, we are then able to say, okay, this tuskless elephant is more of an elephant than a rhinoceros, which is a similar creature. It's got very thick, leathery grey skin. It has a horn or a tusk of sorts. They live in similar habitats, so on and so forth, but it doesn't necessarily mean that they're the same animal. So this is a point to get across that, okay, this is where we're classifying animals, let's say, but then we can think about it in more abstract terms in the realm of number and geometry and so on and so forth. It is helpful to have this more real world example of standard, non-standard, and non-examples to begin with. So an elephant is an elephant with tusks, standard, or without, non-standard. A rhino isn't an elephant, even though it has grey skin and a tusk/horn. So this flowchart, I think, is really helpful when we're thinking about incorporating conceptual variation with examples, standard, non-standard, and non-examples in our lessons. So you have conceptual variation. What it is, the positive is standard and non-standard. Examples to make sure that you do include both, and then what it isn't, negative, so your non-examples. Now, a way that we've built this into a lot of our MathShed lessons is by using Frayer models. So Frayer models are used to help children build vocabulary. It's not just something that is used in maths, it can be used in literacy, it can be used in topic, history, geography, and science even, to help children build vocabulary. It's just a frame that you can use in various settings. So here we've got examples and non-examples already built into the Frayer model. So for this, we've got unit fractions, and we've got the definition, a fraction where the numerator is 1, examples, so we've got a third and a fifth. We could have more. We have them in their fraction form, we have them in the written form, we have them in a concrete or pictorial way with the beads and the stars. And then we also have the non-examples of 3/5 and 2/3, again presented in various forms. Similarly, they work really well with shape work. So for area, here, this is from one of our MathShed lessons as well. We've got examples, and you can see here that I've used these examples where they're standard, examples of how we might perceive area, with the red section being the area within the shapes. You've got the right angle triangle and the square in kind of a standard format, and then the equilateral and rectangle at an angle to show that, you know, a shape doesn't need to be perfectly horizontally perpendicularly lined up for it to be able to have an area. Lots of different shapes in various different perspectives can have area. And then next we have these unenclosed shapes, these open, they're not shapes, they're just like a series of lines that haven't been connected, and therefore those are non-examples because they aren't an enclosed space, so therefore they can't have an area. Again, we have an example here from the NCETM. This is from their variation handout, showing how they advocate for concept and non-concept examples. So here they are showing that it's helpful for children to hear what they're looking at radius, to have examples and non-examples of radius, so that children can define what a radius or whatever else it could be is by what it is, but also by what it is not. Okay, so moving on to procedural variation. Now, this is something that you see examples in various different training, whether it's from the NCETM, whether we're looking at academic papers that have been written by East Asian educators or academics in Western nations looking at East Asian schools. The thing is, people thought for a long time that there was a lot more rote learning and drilling happening in East Asian schools, when in fact, the variation that they have, procedural and conceptual, built into their textbooks and lessons and how their specialist teachers teach, meant that it was all intelligent practice. So it was reasoning and problem solving hidden in plain sight, let's say. So here we can see all of these different single digit addition sentences, and each one is carefully sequenced. So we start off with these pictorial representation of dots. Then we move on to using numbers within this sort of triangle frame that is being used. And then finally, all of the numbers from inside the representation have been removed and it's only outside, which then increases the difficulty. But throughout, there's this intelligent practice, there's this sequencing, there's this procedural variation from the beginning to the end. Very simple, but very, very clever. Here again, we're looking at what is essentially one-digit addition and subtraction from three-digit numbers. But the way that this is sequenced, okay, you've got this intelligent practice where children can rely on their knowledge from the previous question to answer the next one in each box. But at the same time, the way this is laid out also works as a precursor to when you're looking at function machines in algebra. So really clever stuff. Again, here, these are all sequenced. So there's slight differences between each question, and it's allowing children to use their place value knowledge as well as their multiplication skills. Here's an example from some NCTM guidance. There's a series of pairs of questions. And here's the thing, to very, very simply employ intelligent practice in your class is to ask, what do you notice? To have pairs of questions and what do you notice? Simple, not quite a silver bullet, but one to definitely get yourself started. Clearly here, each is double the previous number sentence. Again, you can use word problems for procedural variation by sequencing them, by kind of changing the focus of the word problem, but keeping the numbers employed the same. And then asking the children after these three questions, okay, what do you notice about this series of questions? So there are 4 orange cars and 5 purple cars. How many cars are there in total? 9. Very simple, one digit addition question. There are 9 cars, some are orange and some are purple. 4 are orange, how many are purple? 5. And then finally, there are 9 cars, some are orange and some are purple. If there is one more purple car than orange car, how many cars are there of each colour? So it's relying on the facts that they've carried forward, but the level of reasoning increases with each question. And children hopefully will be able to explain that. So that's intelligent practice using procedural variation with word problems. Clearly in a very simple setting, but it could be applied to other types of number work higher up the school, key stage 2, with greater numbers of digits, multi-step operation procedures, and so on and so forth. Now, finally, this is, I guess, refers back to what I said earlier in the webinar about thinking about using the independent dependent variable analogy from science. So here we can see a lot stays the same. However, with each question, it gets slightly more difficult, and it's really looking at, right, building children's confidence as well. So there are 9 litres of apple juice and every 3 litres is put in a jar. How many jars are needed? 3. That's a very simple kind of relying on a simple times table fact solution. The same with the next one. There are obviously going to be 9 jars because 1 multiplied by 9 or 9 multiplied by 1 is 9. Then we're looking at something far more complicated where it's, okay, a decimal number, a number less than 1, can divide a whole number. This is, quite a step up. But the way that these questions have been sequenced, and because there's that constant, there's that unchanging variable to begin with, the 9 litres of apple juice, it gives children something to hook onto, but also something to explain and explore. And just because the starting number is the same doesn't really detract from the difficulty of the question. So if this was just variety, you just have a random assortment of questions. But here you have variation because only one thing is changing each time, which allows children to really explore and express their understanding of the concept of a larger number being divided by a smaller and smaller number, a number less than 1. So here, the researchers that included this in their paper, Munulai and Sarah Murray, say, in this series of tasks, the total amount of apple juice was kept constant while the amount in the jar was varied from a whole litre to less than a litre. This exercise might be considered rote drilling if computing for a correct answer is the focus. However, an experienced mathematics teacher will organise this series of tasks hierarchically and provide scaffolding to illustrate and generalise mathematical ideas. So here, as the amount that's going into each jar decreases, the number of jars increases. And that's the point that you would want to explore and discuss and ensure your pupils understood and were able to express. And because these questions have been sequenced in this way, you're almost certain to allow them to walk it onto that discovery, let's say. Okay, so that is it from me. I'm going to pass back over to Karis now, who will show you some of our resources and how we've gone about ensuring conceptual and procedural variation in our MathShed resources.
Oh, brilliant. Thank you. I think because I've put you as a host, I'm not sure if I can put my video back on, but everyone has seen my face already. Let me see if I can share my screen fine, so that's fine. Okay. Right, okay. So what I'll do is I'll just go through our EdShed hub and show you our different MathShed resources, where to find them and how you could possibly use them in class. So our EdShed hub, if you have already got a subscription, will look like this, no matter which one that you have got. And any resources can be found in the resources folder. And we're just looking at our MathShed today. And our MathShed resources go from reception up until year 6. And within each folder, we have the different blocks for the different terms. and enough PowerPoints to use within daily lessons. So I'm going to focus on some of the different variations that Alex has mentioned today and show you how we utilize these within our scheme. So if I click into block 2, addition and subtraction, for example, and then we'll go to lesson 3. Now, for each of our lessons, we have resources, which are the teaching PowerPoints that you can use on the interactive whiteboard as main input for your class. We have question sets, which are quizzes which accompany these PowerPoints and focus on that specific skill. And then we have lessons, and these are videoed lessons by either myself or my other colleague. We're both trained primary school teachers, with bits of media talk time, so short videos that the children can watch, embedded with some quiz questions as well. So I'll show you what these look like. So if we click on the teaching resources, first of all, and then I share this one. So here's our stage 1, autumn block 2, lesson 3. So they all have the same structure with a success criteria and a starter, first of all. And then you can see, as Alex mentioned, some of the different variations that we have within here to teach the children within our scheme. So we're looking here at the part whole model, using to complete the calculations below, and how they can use the 2 parts and knowing the total to complete these, and knowing that the equal sign can change where it is, but it does just mean it is equal to. So 5 is equal to 2 plus 3, example. If I go down, so we've got some different things that you could potentially use on their interactive whiteboard. Of course, you can alter them and amend them for your class if need be. And then we've got activities going through these. So you could get these for pupils to do on whiteboards, or maybe in their books, or if you wanted to print them out, you can also do that as well. So we have activities going through them, changing how we lay this out and doing different visual representations, such as here we've got the bead strings, and we use deans and cubes, all sorts without. So here's just a bit of a look at how we use these variations within our lessons. And then at the end of each lesson, we have an evaluation, like a plenary, where we might have Astroby, who's our MathShed character here. It might be a prove it statement or spot the mistake, something that utilises the learning in their lesson to solve a bit of a problem and prove what they have learned within the lesson. Just a slight bit of assessment that you can use. So if I go back to MathShed, and then I'll show you the accompanying quizzes which go along with these. There we are. So you can also print the activity slips as well if you'd like to, and use them for home learning or within class. So these are the quizzes which accompany each of the PowerPoints. So you can generate them as a worksheet if you would like to. If you don't have the devices for children to play on, you can also assign them to children so that they can play the quiz through their MathShed login. And I'll just show you what that quiz will look like. So you can choose a number of questions, and you can get this to be read out, as some of your year 1 children might need that.
Look at this part whole model. Which calculation is not correct? Select an answer below. 2 equals 3 plus 5, 3 plus 2.
So you can see within these questions, they are set out slightly differently, just to keep a bit of motivation. And you can see the more I get correct, the more I sort of get these ticks in a row. So you can sort, you can input numbers, they might be multiple choice. So quite a lot of variation within the types of questions and how they're visually represented in our quizzes. So once the children have done those quizzes, you can see how they got on. I'll show you that in a moment. I'm just going to show you our lesson side of things. So this is what our lessons look like, and you can assign these for the pupils to view on their logins as well. These are really good for interventions. Maybe you want to assign these to pupils and they can log in and have an adult with them as they go through these, or consolidation, or for some sort of home learning. So I clicked on these earlier, but you can see how the others are blurred out and I'm forced to go at the start. It's only green because I did click on them earlier. So they'll have short video clips for the starter, for example. Today we're going to learn how to use addition fact families. For this starter, which one doesn't belong? We've got a part whole model here, a number sentence, and 2 sticks of cubes. So then they can watch that and get a bit of an idea. And then we've got an explainer video for activity 1, which again gives the children just some more examples as they go through. Now we're going to use the part whole model to help you complete the calculations below. You can see we have the total at the top and then the 2 parts. So we've got 2 add 3 equals 5. Something add 2 equals 5. So that's good. And then once they've done that, they have then been presented with quiz questions on that specific skill to do with that activity. So you can see here, that's just the activity that I was describing within that video. And you can go on just like that. And they go through the different activities and videos within the lesson, just like a bit of a playlist. So it's more or less a playlist of videos and quiz questions. There's another one I was just going to show in Key Stage 2, because we've obviously just done a Key Stage 1 one here. If we go back to MathShed and we'll look at Year 4 and one of the shape lessons and the different representations used within this. It's worth noting as well that for each of the end of terms and the end of blocks, we have assessments. And these are exactly like the quizzes that I just showed you. You just allocate them to the pupils to access on their logins, and it will give them questions that sum up, that cover the objectives of either the block or the term that they have just done. So that's block 5, properties of shapes, and lesson 4. Now I will just go through the lesson here. And you can see in this one how we use the Frayer model that Alex mentioned previously. So again, we've got our success criteria, the starter video. Hello, and today we're going to learn how to identify various quadrilaterals. And then our activity 1 is the Frayer model. So you can see how I've got to do a non-example, an example, definition, and characteristics. And what pupils can do here is upload an image. So if they have an iPad, they could screenshot this and input that information, which you can later review. Then we've got activity 2 with some quiz questions on what we have just learnt. If I just click through them. You can read the different questions. There is a timer at the top. You can disable this if you want to. It doesn't actually go on to the next question if you let it run out. So there are lots of different opportunities for children to sit and work it out, or if there's lots of text, such as there is on this question, they've got time to read it. It's just a motivational tool. I'm just going to click through them. If we just have a look at the PowerPoint that goes with this one, and then I'll show you what it looks like when we allocate work to a child. Okay, so if I just show you here and just go through quickly, you can see the Frayer model, what that might look like filled in. Different activities, so activity 2, they're doing definitions. And then we've got talk time doing different examples that we've got here. Ones where shapes aren't always exactly straight, as Alex mentioned before. And lots of different opportunities to practice this skill taught within this lesson. Now in MathShed, let me go back to it, there it is. what we call work that's allocated to a pupil is an assignment. Now, in MathShed, you can have two types of assignments. You can assign actually three different types. You have got fluency skills, which I'll go on to in a moment, and you can assign the quizzes and the lessons that I have just demonstrated. When you've assigned something, you can see here how the children have got on. So whatever it is that I've assigned, you can see how many times they've played that, how many percentage that they've got correct, the difficulty that they chose depending on what the assignment was, and the score that they've got. And then they can go up in assignment status. This changes depending on how many points that they've got. If you want to view some more in-depth information, you can click View Pupil, go into, oh, I'm not quite sure what's going on there. Hang on. Sorry, this is my test account. So let's have a look. Go. Right, that's what I needed to click on. Okay, so if you click View Pupil, you can then see here the different maths data. If we go into there, we can see things such as if I've given them times tables and I've given them the 2s to 12s multiply, for example, you can see their progress over a particular amount of time. You can see here, this is just my test account. So you can see here, I've actually got slower per second per answer, but you can see the total answers over time has increased, and you can see the history of this child and what they have played and their exact answer. And you can see the answers for the quiz questions here too. If I go into the game screen, which you can do with either of these yellow buttons, and you can do this if you want to get a free trial today. The trial ends after 30 days. You don't have to worry about cancelling it or anything like that. And we go into MathShed. Now, depending on how you set work, there's a button when you set work to, if you choose to, limit the children to seeing only what you as the teacher has set. I don't have any work for me here. This is just my teacher account. So because I don't have any work set, I can see everything, but this is ideal to be able to show you. So in our fluency skills, we have things like number bonds, which you can play, and times tables, all of those different things. And this is what they look like. We also have our year 4 times table simulator as well, which looks very similar, just multiplication. So those are our fluency skills. So the key arithmetic skills. Then here are the quizzes and lessons that go with each year group. So if I click into year 4, for example, and the one that we were just looking at, here's the quiz that goes with that lesson and the lesson that goes with that lesson. So it will look exactly the same as what I showed you earlier. Here is also, if I click on one, let's see if I can find a, I think it's because I'm in the teacher section. You can also have the end of term assessments appear here, but because I'm in the teacher section, I don't have it assigned to me. It's not coming up. But they are exactly the same as the quizzes that I demonstrated. They will just definitely go through the objectives that you want to assess. So that's what it looks like. And if we go on to maybe times tables, I'll just show you what these look like. So here's the year 4 multiplication check, for example. And you can see those here. So what I recommend that you do is to get a free trial if you would like to, and have a click around, have a bit of an experiment. You can also add children accounts to your free trial, and then you can put them into a group if you'd like to and see what they make of it, and see if it suits the pupils within your class. But unfortunately, my video isn't working at the moment. If I click stop share. But thanks so much for watching today. And if you've got any more questions, if you email support@edshed.com, one of our lovely support team will get back to you. All right.
Thanks very much. Thanks for joining us.
And the recording will also be on our YouTube channel, but I will email the link after. All right. Bye, Alex.
All right.